How about another application of integration by parts? Now, when I look at this integral, I notice if I split that integrand up into the product of these two factors, that kind of looks nice. I can anti-differentiate that, and I can differentiate that factor. Kind of suggests that I should play this game, because I could differentiate that. And I can anti-differentiate that, paying the consequence of my actions. Anti-differentiating. So this becomes a product of my u and my v. Minus the integral of all my d involving my v du. But we are trigonometric experts, so maybe employ my second version of my Pythagorean identity. Allow me to rewrite the second factor in the integrand's position. Now, in adding this integral, or I should say adding this whole term to both sides of the equation, doesn't that give me this? Because I have no more integrals. Well, actually, I do, don't I? So everybody, next, take a peek. Still the integral of secant cubed. Here too, just like the original question, I don't know how to anti-differentiate that. Well, I should say, I don't know its antiderivative off the top of my head. So I'm going to take a short break. I will pull out a nifty piece of scratch paper, and I will ascertain what that integral values to. So allow me and pay the consequence. Apply my integration by parts formula. U times V is this. My V du is this. And I'm integrating it and subtracting. Yet again, my second Pythagorean identity gives me another name for this. Adding this to both sides, and simultaneously evaluate that integral, but you did that in your first semester calculus course and learned that an antiderivative for the secant of x is really this. And now, in isolating this integral, and now going back, now that I've evaluated this integral, it was addition plus. Well, that leaves you with this. And shall I say, finally, I can answer my question by merely isolating this interval on both sides of the equation. Did I say that correctly? I've answered my question by isolating this interval on the left-hand side of this equation. Well, that was a mouthful.